Pentagon is building drones mounted with lasers that can destroy enemy missiles before they have left the launch pad. The U.S. Missile Defense Agency has requested $66 million, £48 million, in funding to continue the top-secret program, with a plan to begin tests by 2020. Officials hope that innovative missile-intercepting technologies will help the U.S. military to defend sites like Guam, Japan, and Hawaii from North Korean attacks. Named Low Power Laser Demonstrator, LPLD, the project aims to build lasers that can be mounted onto a drone and used to take out missiles before they are a threat. If enough of the laser drones are in the air, they could even neutralize missiles in the air shortly after they have left the launch pad, reports DefenseOne. The agency has been developing the laser system for some time, and the funding it receives will help it continue the project for the foreseeable future. Last year, the U.S. military gave contracts to Lockheed Martin, Boeing, and General Atomics for the solid-state fiber laser program's first phase. Each company will present its own solution to the Pentagon before 2019. U.S. officials will pick one to continue, with a goal to have something ready for testing set for 2020. With drones and other unmanned vehicles set to dominate battlefields of the future, the Pentagon has invested billions in the technology over the past decade. In January, the U.S. military launched a new competition for the design of laser-powered drones inspired by bats and insects. The Department of Defense said its new DESI pilot program is seeking proposals for a number of topics that currently stand as defense challenges, including highly maneuverable drones. The competition aims to pave the way for autonomous craft that can operate more efficiently with little intervention from a human pilot. Specifically, officials are looking for craft that make swift decisions to change direction and avoid obstacles. According to the announcement, the Defense Enterprise Science Initiative program is seeking to devise new paradigms for autonomous flight, with a focus on highly maneuverable platforms and algorithms for flight control and decision-making. This year's competition is designed to focus on sensing, mobility, and autonomy. The biological study of agile organisms such as bats and flying insects has yielded new insights into complex flight kinematics of systems with a large number of degrees of freedom and the use of multifunctional flight surface materials, last month's announcement stated. Progress in sensors, optimization, and miniaturization of processors, and advances in flight control algorithms have also made it feasible to enable real-time autonomy in a miniature robotic system. As a result of these advances, there exists a possibility of creating autonomous unmanned aerial vehicles (UAVs) that have significant improvements in maneuverability, survivability, and stealth over traditional quadcopter or fixed-wing designs.